Welcome. In this video, we are going to look at or to learn how to solve problems involving area under a curve. Now, to solve problems involving area under a curve, we always use the integration method. Now, let's see or look at this example. Find the exact area of the region Q enclosed by the curve y is equals to x squared, the x-axis, lines x is equals to 2 and x is equals to 4. Now, when you plot this curve on our Cartesian plane, it will look like this. Now, we have this curve y is equals to x squared. Then we have lines x is equals to 2 and 4. Now, we have this region here marked Q. The region is shaded. So we want to find the area under this curve y is equals to x squared, the shaded region Q. Now, in our case, lines x is equals to 2 and x is equals to 4 are our lower and upper limits respectively. Now, to solve this or to find the area marked Q, we are going to use the integration method. So solution. Now we are integrating curve y is equals to x squared with lines x and 4 as our lower and upper limit respectively. Now we are integrating the curve y is equals to x squared. Our lower limit is 2 and our upper limit is 4. So this is a definite integral like that is equals to, now integrating here we add the power by 1, then divide by the power. So when we add 1 to 2 is 3, so it will be x cubic divide the power which is 3. Then of course we have our lower limit as 2 and our upper limit as 4. Now, next step, we substitute. Where there is x, we substitute with 4, then subtract. Where there is x, substitute with 2. So it will be 4 cubic over 3 minus 2 cubic over 3. So of course, when you solve further, we have 64 cubic is 64 over 3 minus 2 cubic is 8 over 3. So 64 over 3 minus 8 over 3, you will get 18 whole number 2 over 3 square units. So this is the area under the curve y is equals to x squared, the area of the shaded region Q.